So far, we have only factored polynomials. So now we're actually going to solve. It's the exact same process, but now instead of leaving it in factored form, you need to take it that one extra step and solve it. You are still using your steps from example 5. List your possible rational zeros, figure out what you can eliminate, find your zeros. So in this one, we need to find my possible rational zeros by doing P over Q. My P is 2 and my Q is 3, so I will have to go through the process of this one. So P is plus or minus 1 and plus or minus 2 over Q, which is plus or minus 1 plus or minus 3. So 1 divided by 1 is plus or minus 1. 2 divided by 1 is plus or minus 2. I did 1. Now I'll go to 3. 1 divided by 3 is plus or minus 1/3. 2 divided by 3 is plus or minus 2/3. So I have 8 total numbers here that I could have on this graph. So remember, rational, if we get square root, it's not going to be listed here, but fractions are still rational. So now let's use our graph to figure out what we can eliminate in at least one of these zeros. So we'll enter this in. Okay. I'm going to go to window. I know my smallest one is possibly -2 and my biggest one is also 2. So I'm going to go -3 to 3 and graph. All right, the easy ones that it could be would be the whole numbers. Well, it's not crossing at 1 or 2 or 1 or 2 here. So I know it's not either of these. So hopefully it's one of these fractions. Because we can get fraction answers, this is why it's so helpful to be able to list this out. Because if I look at this, I might be guessing 1/2. And 1/2 isn't even one of my possible rational solutions. So this is why this is so important, especially when you get fraction answers, so that you have somewhere to go. So if I try 1/3, I'm going to go trace 1 divided by 3. That's not it because y is not 0. So let's try -1/3. Well, I can tell that's not it, right? -1/3 would be somewhere over here. Okay, so it's not 1/3. So let's try 2/3 because I can see it's not -2/3. -2/3 would be over here as well. So 2 divided by 3. And there we go. We get y is 0. So 2/3. And we got this from our calculator. Let's use synthetic division to divide this out now. I've got x cubed, x squared, x and constant, so I don't need any 0 placeholders. So we'll put our coefficients of 3, 4, -7, and 2. Bring down your first one and multiply, add, repeat. 2/3 times 3, these 3's eliminate, and you're left with 2. We add and get 6. Multiply, 2 times 6 is 12, divided by 3 is 4. Add, and we get -3. -3 times 2 is -6, divided by 3 is -2, which gives me 0. Okay. If you're not good with those fractions, just literally put it in your calculator. 2 divided by 3 times 3, we got 2. 2 divided by 3 times 6, and we got 4. So use your calculator. So I now have this right here. Here's my remainder, so I know that I found this correctly. This is my constant, my x, and my x squared. So I have x squared plus 6x minus 3 equals 0. The easiest thing to do here is to factor. I can't use square root property because I have a b term, right? So the next thing is factor. So if I go into my x, my a times c is 1 times negative 3, and my b is 6. What adds up to 6 but multiplies to negative 3? I'll give you a minute. Your only multiples to get to negative 3 is negative 3 times 1 or 3 times negative 1. Neither of those add up to 6. So because there is nothing, this means we have to use the quadratic formula. Here we go. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. My negative b is a negative 6 plus or minus the square root of 6 squared minus 4 times a times c all over 2a. I'm going to get negative 6 plus or minus the square root of something. We'll figure that out, all over 2. So let's put this in our calculator. We got 6 squared minus 4 times negative 3 to get 48. And I kind of messed up a little bit. Let's rewind a second. And I'm actually give you a minute to figure out if you found out where I have messed up, if you have not already seen it yet. Pause this video if you want more time to try and find my mistake. My quadratic equation here should have been 3x squared. The same thing would have applied when we went here though. 3 times negative 3 is negative 9. There's still no way for me to get to a positive 6 when this is negative. You would say 3 times 3, that will give me 6, but 3 times 3 will add up to a positive 9. The only way to get to a negative 9 is negative 3 times negative 3, which would be 0 when you add, or negative 9 times 1, which is negative 8, or you could get a positive 8 switching the signs. So we still would have had to use quadratic formula. It would have changed though when I plug in to both of these 8s. So this would have been 4 times 3 over 2 times 3. So this is all over 6. And let's figure out what goes under here. You know, there's just nothing better than making a complicated problem more confusing by making mistakes. So, yay. 6 squared minus 4 times 3 times negative 3. Let's try 72. Boy, oh boy. Okay. Made the mistake here. This is supposed to be 3x squared. When you try and do your x, it doesn't work out. I rewrote my formula, so now plug in a is 3, b is 6, and c is negative 3 into your formula, simplify, and now we're here. Whew, okay. Now we need to simplify 72. You can do 8 and 9, but the easiest one's going to be 36 and 2, because 36 is 6 and 6. So that comes out. Our lonely poor 2 stays in. So we get x equals -6 plus or minus 6 square root 2 all over 6. Because -6, 6, and 6 are obviously all divided by 6. Let's divide them all by 6. It does not matter that 2 can't be divided by 6 because we do not mingle what's under radicals with what's outside radicals. So -6 divided by 6 is -1. 6 divided by 6 is 1. So I could do 1 square root 2. But I'm just going to do square root 2. And then 6 divided by 6 is 1. You can put it all over 1, but that's not necessary. So now that we have factored or solved this portion here, let's now go back and answer the question. Find the real solutions, use exact values of this equation here. Well, we found one from the very beginning. Yeah, let's do that. We found one from the very beginning of 2/3. And then I factored out this quadratic to get these two answers here. -1 plus or minus the square root of 2. So this is my final answer here. So when I am looking at my graph, we can check this. We've already done, oops. I haven't hit trace. We have already done 2/3 is 0. If I put in -1 plus the square root of 2, we get 0. And if I do -1 minus the square root of 2, we basically get 0. There is a way on here to do second calc, and you can use the zeros here to find the approximated amount. And when you find that approximated amount, you would end up getting, let me see. You would end up getting these decimals here. You get about 0.414. But because this says it wants the exact values, if you give me these numbers here, you're not getting full credit. In fact, you're not going to get a lot of credit at all. If it wants exact, you've got to have the square roots in here. Exact means no rounded decimals.